So this is second lesson of the vector that we are going to take. In yesterday's lesson, the first thing that we have learned how to write the position vector when the coordinate of a point is given. For example, if you have a point A, it's xy, its position vector will be OA. Position vector is always the vector that we write from the origin. So OA will be written in the column vector form as xy. Like if the point has a coordinate minus 1, 3. So what will be the position vector of P? OP. It will be minus 1, 3. Now, in the same way, the second thing that we took in our yesterday's lesson, it was AB vector will be how we can write a vector in terms of the position vector, it will be OB minus OA. Like the later point position vector minus the initial point position vector. Then we have learned about the addition of the vectors and subtraction of the vectors. So let me take an example here. So let's say, for example, here a vector is given in the form of a column vector. The vector A is 2, minus 3. Vector B is minus 2, minus 1. You have to work out 5A minus 4B. So first, how I will find 5A? 5A mean I told you if we multiply a vector with a scalar because the numbers are scalar. So we will multiply the scalar with both. Like I will multiply 5 with both. It will be 10 minus 15. And if I have to find this 4B, because to work out this one I need this. What will be 4B? It means I have to multiply both with 4. So it will be minus 8 minus 4. So what will be 5A minus 4B? Mean write these two vectors 10 minus 15 minus 8 minus 4. So let's do, how do we do that? This component, this is called the x component. You know, if I write the column vector, we call this x component, this is called the y component. So x component from the x, like 10 minus this minus and minus 8. And minus 15 minus 4. So what it will become? 10 plus 8. And this will become minus 15 plus 4. So finally it will be 18 minus 11. So this will be 5A minus 4B. So always if we have to multiply a vector with a scalar, you will multiply that number with both the components of that vector. Okay? And again, I told you before the start of the class even, I have shown you that yesterday's class video I have uploaded. Why I uploaded it immediately so you guys will be. So this explains complete basic concepts. So go through that, watch it as well. Okay? Let me take another example here and we will see. For example, if I have Abdurrahman, don't worry, you will understand. If this is C and this is D, and you have to work 3C plus 2D. First of all, I have to find 3C because I want to work out 3C plus 2D. So what will be 3C? 3C mean the C vector, the both components of the C vector I will multiply with 3. So it will be minus 21 plus, and this will be 9. Now in the same way, I need 2D. So how I will get the 2D? 2 will be multiplied with both components. So it will become 8, 16. So now I want 3C plus 2D. So I mean I will take 3C. In place of 3C, I will write the 3C column vector. It's minus 21, 9 plus this 2D. This is 8, 16. Okay, so let's add minus 21 plus 8 and 9 plus 16. So what I will have from this one, minus 8 plus minus 21 plus 8, it will be minus 13, and 9 plus 16 will be 25. So it means your this vector will be minus 13, 25. Okay, I hope so. Now this concept of addition and subtraction is clear. Let me take one more example here, and then I will move to our next concept that we have to take today. Let's say I have three vectors, column vectors. This is C, D, and E, and I have to work out 8C plus D plus 2E. So first I need 8C. What will be 8C? It means 8 will multiply with both components of C. So it will be 40 minus 24. Okay, D already we have, so then 2E. So 2E is going to be 2 will multiply with both 24, 12. So now let's take what you have to find. We have to find 8C plus D plus 2E. So 8C is this 40 minus 24 plus D is minus 2, 5, and 2E is 24, 12. So as I told you, if you have two vectors, we add the x component. In the same way for three vectors, for adding or subtracting, we add or subtract the x component with x and y with y. Like 40 minus 2, 24. It will be 40 minus 2 plus 24. Minus 24, 5, 12. So what that is going to be, it will be 38 plus 24. It will be 38 plus 24, 2, 1, 62. Now, what is that one? Minus 24 plus 5 is minus 19 plus 12 minus 7. So this will be. So remember now, before I proceed forward, if you have two vectors, like vector A is x1, y1, vector B is x2, y2, the one that is on the top is called x component, because you know if A is as xy and we write the position vector of that one in the form of a column vector, it is written as xy, and the column vector will be always starting from the origin. So if it is for example, if this is A is written in this form, B is in this form, so what will be A plus B? We will add the x component with x component and y component with y component, y1 plus y2. Okay, so the sign, for example, if you have to subtract, so you will just subtract them. So this is what we did here. And another thing that in yesterday's lesson we took, if for example, if you have like the vector A is xy and you want to multiply any constant with it, so this constant should multiply with both, like kx, ky. Like let's say A is 1, 2, and you want 5a. So 5 should multiply with both components. Okay, it will be 5, 10. And then addition will be x component with x component and y component with y component. We took all this yesterday. Today, the first thing that we have to take, it is the magnitude of the vector. Magnitude of vector. Because we know the vectors are those quantities which need direction and magnitude. So how do we find the magnitude of a vector when it is given in the column vector form? Let's say you have a vector A, it is in the column vector form written as xy. The magnitude of A is represented by A magnitude or A mod, short form of that is A mod or A modulus. How do we find that one? We take the x component square plus y component square root. This is how we find the magnitude of the vector. Let's say, for example, if you have a vector A, it is minus 1, 4, and you want to find the magnitude of A, So how would you find the x component square plus the y component square? So if you calculate this 1 plus 16, 17 square root will be its magnitude. The magnitude of this one will be this. Okay, that's very simple. Like let's say I have a vector. Yes, sir. Yes, sir, Abdurrahman. Yes, Abdurrahman. I'm all ears. Let me know what do you want. Rahman, you said sir, and after that you have. Why do we use the Pythagoras theorem formula? It's not the Pythagoras theorem formula. It's like that. It's like that. Actually, when I will come to the graphical form, you will understand it much better. If we write a column vector, as I told you, for example, let's say this is the point A having the coordinate x, y. So if I will write OA, it will be x, y. Okay. So if this is the origin, you are taking it from here. So what is this x? X is actually is going to be here. This is x and this is y. So this become a right angle triangle, obviously. So the length of this one will be the magnitude of this vector. The length of this one is actually the magnitude of this vector. Like if you take the magnitude of OA, it means you are taking actually the length of this one. So it will form a right angle triangle. So obviously it will be x square plus y square. Okay. But for the detail, inshallah, in the graphical concept, we will take more. Okay. Let's say I have two vectors and I want to find 3a minus 2, sorry, 3c minus 2d magnitude. I want to find this magnitude. So obviously, if you have to find the magnitude of any vector, before that you need that vector. Yes. So if I need to find the magnitude of this one, first I will find this one. So I will find 3c. What is 3c? 3 will be multiplied with both. It's 0, 21. Okay, what will be 2d? Because I need 2d. So 2d will be minus 9, 33. Now, what will be 3c minus 2d? I have to subtract them. 0, 21 minus 9, 33. So let's subtract 0 minus 9, 21 minus 23. So that will be 0 plus 9, it will be 9. 21 minus 33 will be minus 12. Okay. Now, if I have to take its magnitude, so how I will take the magnitude? The x component square plus y component square. Oh my god, you're telling me now. Yes, we multiply with 2, so it will be minus 6. Thank you. It's okay. So it will be minus 6. Okay. So that will be. Then now, use the magnitude formula. How do we find the magnitude of the vector? Because we found the vector. And now for the magnitude, what has happened to me? I'm multiplying with 2 and I'm here actually multiplying with 3. Because in my mind was this one. Sorry. So it's 22. The calculation, please take care. No, this will be 1. Then minus 1. Okay, now calculate. So for the magnitude, you will take the square of this plus the square of the second component. So 36 plus 1, 37 square root will be the magnitude of this vector. Okay? Clear? Okay, next is let's take an example. So two vectors B and C are written there. Hmm? And I have to write them in the mathematical form. These vectors are in the graphical form, and I have to write them in the mathematical form, mean in the column vector form. First of all, before doing that one, I will just recall the concept of axis, if you remember. You know, this point is called the origin, where the two axes cross. This the horizontal one is the x-axis, and the vertical one is the y-axis. The point where the two axes cross, we call it's the origin. If we move on the right side of the horizontal, like on the x-axis, it increases. It's a positive. If we move on that side, it will be negative. If you go up, it's positive. If you come down, it is negative. So for example, if I move, let's say I'm here, I move two step on that side, like one step, two step. So I will say x is equal to 2. Okay. And if I move then two step downward, 1, 2, so mean it will be y will be negative 2 because I moved. So when you move horizontally, it will be x. When you move vertically, it will be y. If you are moving vertically upward, the value of a y will be taken positive. And if you move vertically, horizontally on the left side, it will be x should be negative. Okay. This v is the short form of this. Look, the full word is positive. So short form of the positive, I always write like this, positive. Okay. In the same way, negative is, so the short form of the negative, I write negative. Okay. Now, if a vector is given in this form, how would you write the column vectors from that? Let's say this vector, if you see this is the direction of the vector, it means the vector is starting from here. Yes, the vector is starting from here and ending here. So from here till here, how you are reaching? You are moving two step horizontal, mean x is equal to 2. And then how many step vertical? 1, 2, 3, 4, 5, 6. Mean y is equal to 6. So how do we write the column vector? We write the column vector always as xy. So it means this vector will be 2, 6. Yes, this vector will be 2, 6. In the same way, for example, if I have to write this vector, how I will write? As this is the direction, so I'm starting from here and I am going to this direction. So how I will reach to this one? I will move horizontally, then vertically. So 1, 2, 3, 4, 5. X is equal to negative 5 because I'm moving on the left side. I told you if you move on the left side, the y will be negative. On the right side, it will be positive. In the same way, for y, if you move upward, it's positive. If you move downward, it would be negative. So from here to here, I'm moving 1, 2, 3, 4, 5 steps on the left side, so x is equal to negative 5. One step up, so mean y is equal to 1. So this column vector what C would be? Minus 5, 1. Because the column vector we always write in this form. That will be the column vector. Okay. So this is how do we represent, like if a vector is given, so how we will make that. Okay. Let's say for the example, I will, 1 second. Comfortable on your eyes? Hmm? Or not? Okay, let's say I have this vector and this is the direction of the vector and I want to write the column vector that represents this vector. It's the same thing, but we always write the x first and the y. It doesn't matter how you say it. Okay. Now in this one, this is the starting point. This is the starting point. This is the ending point of the vector. What you wrote, Abdul Rahman? Now, to from here to here, how it would be 1, 2, 3, 4, 5, 6, 7. 7 step I moved horizontally on the right side. This means x is equal to 7. And how many step I'm going vertically? 1, 2, 3, 4, 5, 6. So y is equal to 6. It means the column vector that will represent it will be 7, 6. Okay. If you say no, I want to say first vertically, then horizontally, x, y will not change. It will be same. So the column vector that will represent this one will be this. Now let me write a vector here and tell me what it would be. The direction is very important. It's starting from here and ending here. What will be this column vector? What column vector this vector is representing? Anyone, please? I'm not saying gate 5. I'm not, you're all right, but with a slight mistake. Slight mistake. If you see, 1, 2, 3, 4, 5, 6, 7, 8. So it means x is equal to 8 because you are moving horizontally 8 step. Okay, vertically 1, 2, 3, 4, 5. Vertically y. But you are moving down, so y will be negative 5. It means the column vector, which is always written in this form, we always write in this form xy. So it will be 8 minus 5. 8 minus 5. Not 8 and 5, 8 and minus 5. Because for y you are going down, I told you if you will go down, y will be negative. If you will go up, y will be positive. If you will move on this side, x will be positive. If you will move on that side, x will be negative. So that you have to keep in mind. Okay. One more example and then I will go slightly different than that. What will be the column vector for this one? Let's see. 1, 2, 3, 4, 5, 6, 7. X is equal to minus 7 because we moved on the left side. Yes? Okay. And then y 1, 2, 3. Y is minus 3. So it means the column vector would be minus 7, minus 3. That would be the column vector here. Okay? This is the column vector that we have here. I hope so till now the concept got clear. It should be crystal clear. Okay, let me give you one example. Try it. Can you make the vector D and vector C? In this case, this is the direction, yes, starting from here. I mean, you are not moving horizontally at all. Mean x is equal to 0. And y is 1, 2, 3 step upwards. I mean, y is equal to 3. So the vector D will be 0, 3. What about the C? You are moving 2 step horizontally on the right side. Mean it will be x is 2 and y is 1 step up. So mean y is 1. Alright? The y is 1. So this is the way to find the vector, uh, column vector in the mathematical form when it is given in the graphical form. Okay, let's talk opposite to that one. Hmm? What if a vector is given and you have to draw that one? Like chance can be like a vector is given and you have to draw that one. Let's say I have a vector, this is a vector, and I have been asked to draw this one. How I will draw? No, it is telling me x is 3. X is 3 mean I have to move 3 steps to the right side. Y is 1 mean I have to move 1 step upwards. Now, question will be in your mind from where we have to start. So no problem, you can start anywhere. Let's say I'm starting from here. This is the starting. I have to move how many step? 1, 2, 3 step, and then 1 step upwards. Okay, and the arrow direction I will make. So this is the vector C that I make accordingly. For example, if I ask you make a vector E which is minus 4, 1. So you can start anywhere, like on the grid. It's saying that this x is minus 4 mean you have to move 4 step on the left side. So how would you move 4 step on the left side? You can start anywhere. Like I'm gonna start from here. So 4 step on the left side. 1, 2, 3, 4 step, and 1 step up. Is this one. So obviously, how would you count because you don't have the digital pen, and you will not have the digital pen for the paper. So you will start from here. Like mark the point here. Mark the point. Like mark the point here. 1, 2, 3, 4 step, 1 step up. So this one and join them. You use the scale always, by the way, and then draw the direction of this one. This is the okay. So this is how we will draw the vector graphically. Okay. So now graphically and the representation you know very well. Okay. One more example, leaving for you to do right now. Anybody can draw. I give the permission to annotate. You can annotate on the screen. Anyone would like to annotate on the screen this vector. It. Who annotated this one? Amina? One, two, three, four, five, six, seven. Seven will be actually here. You miscounted that one. It will be here. Starting if you're starting from here, seven and then four step downward. One, two, three, four. It will be here. So you miscounted, but it's okay. Sometime while annotating, you might be. This one is by Abdul Rahman. One. Got it or not? So take care about the number of the steps that you count because both are negative. Negative mean you will move on that side for x and for this side for the y. Okay. So that is now next is the thing that I'm gonna tell you. If you guys will remember that one, believe me, you will never have any problem in the difficult question of the vectors. But I'm pretty sure the modern generation don't want to listen, don't want to keep the things in mind. Let's say if you have the vectors given in this form, like it is this one, A, B, C, and you have like a closed path of the vectors. I ask you find AC. In this one, find AC. So what is the meaning of AC? AC mean you will start from A and you will go till C. So how I can go from A to C? I can go from here to here. Yes. So if it is a closed path and you have to find this one when you know these, for example, let's say you have this one is A and this one is B. It's given like that. So how would you do? For finding AC, there are two ways to reach from A to C. One is this direct way, one is indirect way, like A to B, then B to C. So if you have to find this one, don't go to the direct way because direct way will not help you. You will choose the indirect way, like it will be AB. You will say this is AB plus BC. So this will give you now what is AB? AB is A. BC is B. Let me give you one more example here. Let's say this is A, B, C, D, and I have this is A, this is B, this one is C, and I have to find AD. Now, what is AD? Find the closed path. I have a closed path for this one. I will not use the direct one, but instead I will go along this path. I mean, AD can be AB. Make sure if you are going from A to B, so write AB. Forget what direction is shown there. Okay? It will be like that. AB plus BC. Because from here when you will come, then BC plus CD. Can you rejoin? It is going to end in less than minutes, so rejoin please everyone.